Hey there, everyone. Today we're going to look at dilution techniques. This is a two-part series. I'm just going to go over some basic dilutions and simple dilution techniques, and then we'll get into some more advanced techniques as we get into next week. So in terms of dilutions, you already know that the easiest way to dilute something is just to add water. Okay, so in terms of dilutions, the easiest way to dilute a solution is to simply add more water. Okay, so the amount of water obviously will matter. The more you add, the more dilute it'll get. So we also have to sometimes look at exactly how dilute we want things. But if in general, let's say you have a beaker and let's say it has a certain concentration, right? By adding more water, the concentration will decrease. But that's not the only way. Okay, this is the easiest way, but what we can also do to make something more dilute is to not add as much solute. Okay, so if you can somehow remove the solute from the solution, or just to add less of it if you're making a new solution, that would also work. So 2 would be less solute added, or sometimes removed from a solution. Okay, but if you're going to remove or add less solute, the amount of volume shouldn't really change. Okay, so both of those will cause a decrease in concentration. Now, if you're talking about a gas solution, okay, these two are great for solid, liquid, homogeneous solutions. Okay, but if you wanted a solution of gas to be diluted, okay, then all you have to do is add a different gas. Okay, so let's say this beaker had, oh sorry, this flask had oxygen gas. Okay, so you have molecules of oxygen gas inside, and if they're the only type of gas inside here, you can see right now that these gas molecules are very close to each other. Okay, so there's a certain concentration of oxygen gas. So to dilute it, we simply add a different gas in. Okay. So 3 is to add a different gas. Okay. So maybe this different gas could be nitrogen gas instead of oxygen. So obviously if you add more oxygen, you'll increase concentration, but if you want to dilute it, you add oxygen gas in. Oxygen gas tends to get in between nitrogen gas tends to get in between the oxygen molecules and therefore spacing them out more. Okay, so the new gas spaces out the original gas. Okay, so you spread out the oxygen gas so that they're further apart from each other because you now have a new gas being introduced. So this is great for gas-to-gas solutions. technically, some like adding a new substance in sometimes would also work with solid to liquids, but generally we do want our solid to liquid to remain homogeneous, and it doesn't always work that way if you just put another substance in. But these are really basically three easy ways to dilute a solution. Okay, the easiest again being just using water. Now, I don't want to focus too much on this. I think on page 5 of your part 4 set of notes, I describe each one of these in a little bit more detail. So if you want more detail, you can go into the notes package and read up on it. What I want to get into are some basic dilution techniques. Okay, the one that I want to start with first. So we'll just say that these are, oops, special dilution techniques. I think in the notes package I might have written it as advanced dilution techniques, but there's a couple here. So the first one, we generally just call it a volume-volume dilution. But I like calling it parts dilution. And you'll see why when we get into our example here. So volume-to-volume dilutions, or parts dilutions, as I call it. Okay. It involves mixing together something called a concentrate and water. Okay. So a concentrate is used, and if you remember from our last lesson, a concentrate is simply a substance that, for lack of a better term, more concentrated. That's why they call it a concentrate. So it is a substance with high concentration. Okay. So, for example, sorry, a little ahead of myself. Okay. For example, frozen juice mix. If you have ever made frozen juice from a can, okay, you'll know what this process is like. So let's take a can of juice that's frozen. Okay, so let's say this whole block here is my concentrate. And because I'm using orange, this will be orange juice concentrate. Okay. Now, the easiest way to recognize that you're dealing with a volume-volume dilution or parts dilution is that they often give you some kind of ratio. Okay, so if we're talking about frozen juice mix, it might be something like this. You might see something like a 1:6 dilution. Okay, or it could be written as a 1:6 dilution. Either way is fine, whether you use the ratio or you use the word in, they both mean the same thing. Okay. Now, I'll explain to you the process first. And as we go through the process, you'll most likely understand what is actually happening. Okay, so I have this orange juice concentrate. It's just orange juice that has been intensified. So it's a very strong, a lot of flavor. Okay, it's not meant to be drunk. It's not meant to be served as is. Okay, if you basically just melted this concentrate and drank it, it'd be very, very sweet and very, very strong. So what it's meant is to be put into a larger, perhaps, pitcher. Okay. So in a 1:6 dilution, what we're doing is we're adding 1 part of the concentrate. Okay, so this is 1 part concentrate. And we're going to add water to this. But how much water? Okay. A lot of you probably would say 6 parts water because you have the number 6 here. But it's actually not 6. 6 is the total number of parts. Okay, so if you already added 1 part, what you're adding in is actually 5 parts water. Okay, so if you have 1 part concentrate, 5 parts water, the orange juice that's made isn't going to be as strong. Okay, it'll be a little bit weaker because it'll be diluted with 5 parts water. So the 1:6 dilution, okay, that we get, the first number is always the number or parts of concentrate. The second number is the total number of parts. In the solution. Sorry, instead of in, let's say, of the solution. So total number of parts of the solution. Okay, so if you want to find out water, it's always the total minus the number of concentrate. Okay, so what this kind of thing can do is parts can mean any quantity, right? So parts can equal any volume. Okay, it could be 100 mils, 200 mils, 300 mils. Okay, it doesn't matter. If a part is 100 mils, then I have to add 500 mils water, and the total will be 600 mils. Okay, so let's switch the color. So because it could be any volume, let's say 1 part equals 100 mils. That would mean I have 100 mils of concentrate, okay, and I would have 500 mils water to make a total of 600 ml solution. Okay, I could change that if I don't like 100 mils. Let's say I wanted more. Let's say 1 part was 1 liter. Okay. I can have 1 liter of concentrate. That would require me to have 5 liters of water to make 6 liters of solution. So without actually defining exact amounts, if we just use the part system is flexible enough so that anyone can make the same concentration of substance, but at different volumes. Okay, so if I wanted a lot of it, I can make a lot of it. I just have to have enough concentrate. Okay, so hopefully that makes sense. I'm using 1 in 6 as an example, but you can have any number. Okay, so we can have, let's say, a 1 in 10 dilution. Okay. A 1 in 10 dilution would be 1 part concentrate plus 9 parts water. Or perhaps I wanted, let's say, a 2 in 5 dilution. A 2 in 5 would mean 2 parts water, or sorry, 2 parts concentrate plus 3 parts water. Okay. So the second number here is always the total. You take the total minus the concentrate to get the amount of water. Okay, and this is, again, a very, very useful way to dilute something, okay, to almost any volume that's necessary. Okay. The second method of diluting is a little bit trickier, but it utilizes this parts dilution concept. Okay, it's called serial dilution. Okay, so serial dilution is a method of diluting. Oops. Okay, so it's a method of dilution using volume to volume ratios in a systematic kind of way. Okay. So there is a procedure to what we're doing, and that procedure has a very orderly fashion. So that when we dilute something in this way, we always get the same kind of dilution. Okay, and we can dilute things that are concentrated to something very dilute very easily and very quickly. So it's also a very quick method. It's a quick method of diluting highly concentrated samples. Okay, especially in biology. Yeah, we use it in chem as well, but this process is used in biology quite a bit. So let's look at an example. And I'll give you 2 examples here, but the first one we'll look at a serial dilution like this. Okay, so we always start off with a more or less a concentrate. Okay, so again, I'm just going to use some color here. Let's use red this time, and I'm going to make this a very dark color. Okay, it's a very concentrated sample. Kind of looks like blood, and I guess you could actually dilute blood in this way too. Okay, but I'm not going to call it blood. I will say that the starting concentration or original concentration is 2 molarity. So whatever this red substance is, it has 2 molarity. And I'm also going to note that we have 10 milliliters of it to begin with. So this is the original. Now I want to dilute this. Okay, I want it diluted by a factor of 10. Okay, right now it doesn't matter what factor I use, to be honest. Okay, but if I were to take another test tube, and I'm going to draw it right about here so I have enough room. It's the same size test tube, but what I'm going to do is I'm going to transfer 1 milliliter. Okay, so from the 10, I'm going to transfer 1 milliliter of this substance into this test tube here. Okay, and then I'm going to add 9 mils of water. Okay, so when I'm adding 9 mils of water, I'm going to dilute it. So here's the thing. Let's say I mix these two together. Okay, it won't be as concentrated as my original. It'll be more diluted. Okay, so that's how I'm going to show diluted. I'm just going to show that it's not as intense red in color. In the end, you still have 10 mils of this solution, but the concentration is different now. Okay, so what is the molarity that we have? That part is actually easy to figure out. Okay, because what we have done here is exactly a 1 in 10 dilution. I added 1 part of my concentrate, 9 parts water. That's 1 in 10. So in terms of how my concentration changed from the beginning, it started with 2 molarity, but because it's a 1 in 10 dilution, you're multiplying it by something called a dilution factor. Okay. A dilution factor is just how many times diluted is this compared to the original. Okay. So right now it's 1 over 10 because it's a 1 in 10. So if I take 2 times 1 divided by 10, that gives me 0.2 molarity. That is the concentration of my second test tube. Okay, it is 10 times more diluted than the original. Okay, so I said that this was a systematic process because if I wanted to make it even more dilute, I simply take another test tube. Okay, but this time, instead of taking 1 mil from the concentrate, I take 1 mil from my second test tube. So I'm going to transfer 1 mil from this second test tube. Okay, so 1 mil of the 0.20 molarity, and I'm going to add, again, 9 mils of water. Okay, what's my total volume? 9 plus 1, which is 10 again. But it's not the same concentration as my other two. In fact, this turns out to be way less concentrated. Okay, so again, the color will start to go from a really deep red to a very faint red, okay, because it is not as concentrated. So the question again is, what's my molarity here? Okay, well, it is another 1 in 10 dilution, right? Going from this step to this step, okay, from test tube 2 to test tube 3, it's still a 1 in 10 dilution. So we take 0.2 molarity times 1 over 10, which is basically dividing by 10, and that gives me 0.02 molarity. Okay. So again, I've diluted it another 10 times. Okay. The beauty of this is that when I compare it to the original, okay, here's my original concentration. It's 2 molarity. This is my current concentration, 0.02. Okay. Between these two here, these two numbers, the third test tube is 100 times more diluted. Okay, than the original. Right? The second test tube is 10 times more diluted, but the third test tube is 100 times more diluted. We were able to dilute that in just 2 steps, basically. Right? And that's why this is a very quick process, and it's a very easy process. So that 100 times more diluted, it came from 1 over 10 times 1 over 10. Excuse me. Which is 1 over 100. Okay. This little fraction here, these are called dilution factors. Okay. It means how many times something is diluted. Okay, but instead of just saying, oh, how many times is something diluted, it's just easier to say dilution factor. Okay. So again, these dilution factors, we can also, it doesn't always have to be a 1 in 10. It could be a 1 in 5, for example. So let's just take one final look at that. Okay. So you have an idea of how this works. Okay. So let's say again, this is a 2 molar solution, but this time let's say we have only 5 mils. Okay. If I take 1 milliliter of the 2 molarity and I add in 4 mils of water, okay, it's going to be diluted. Now, what type of volume to volume dilution is this? Well, you've only taken one part, so there has to be a 1 in here. You've added 4 mils of water. Okay, so 4 plus 1 is 5. So this is a 1 to 5 dilution or a 1 in 5 dilution. So again, I'm just showing you the two ways that we can write that. So when we do something like this, in order to calculate the actual dilution, okay, I use my dilution factor of 1 over 5. So 2 times 1 divided by 5 is 0.4. Yes. So it'd be 0.4 molarity. Okay. If I did that again, okay, I take 1 mil from here, add 4 mils of water. It's another 1 in 5. So now I have 0.4 molarity times another 1 over 5 dilution factor, and that becomes 0.08 molarity. Okay, so if you look at our starting amount, it's 2 molarity reduced down to 0.4 molarity, diluted to 0.8 molarity, 0.08 molarity in 2 steps. But because we're using less water, it's not as diluted as our first example. The first example was diluted to 0.02 molarity in 2 steps. Here, we're still at 0.08, which is more concentrated than the previous example. And that's only because we're doing a 1 in 5 dilution. Okay? So hopefully this wasn't too bad. Okay? I actually really like parts dilution. I like that it's always the same every time you go from step to step, and the changes are relatively easy to understand as well, okay, and to calculate. So that's all I have for this type of dilution.